analyze this motion quantitatively. That is, the component of velocity we can consider, the component of field we can consider, and the component of force we can consider. Then we can the total force acting we can calculate, and we can give a frequency also. The equation of motion here using the Newton's formula. So we can start with the velocity component here. Velocity is here in the z and y direction. So in the x direction there is no velocity, and there is a y component y dot, and there is a z component z dot. So the b is only in the z direction, that is bz. Bx, b is in the x direction, that is bx here. Electric field is in the y direction, that is Ey. So what is V cross V? For finding the Lorentz force, we have to calculate V cross V. So what is V cross V? For V cross V, we can take the determinant, that is Ijk. Then what is V? V here is 0, here y dot, here z dot. Then what is V? V here is V, that is Vx, 0, 0. So V is in the z direction. So V is in the z direction. So what is this quantity? This is nothing but I into this will goes to 0, that is 0 minus 0. Then j cap into minus j cap into this into this 0, so Vx minus Vx z dot. Then the third term is plus k cap into this 0 minus Vx into y dot. So V cross V is equal to minus plus, that is Vx z dot into j cap minus Vx y dot into k. This is the V cross V component. So what is F magnetic? F magnetic is equal to Q into Vx z dot j cap minus Vx y dot k. What is F electric? F electric force is equal to Q into E. E is in the z direction, so Ez. Q into Ez. Next we can apply the Newton's law. Newton's second law, that is F equal to ma, and compare this equation. So what is total force? Total force is equal to Q into Ez. Ez, which is in the k direction, plus Vx z dot j cap minus Vx y dot k, which is equal to mk. Then what is a? M into what is a? Y double dot in the j direction plus z double dot in the k direction. Then you can compare both the sides, left hand side and right hand. You can compare, and you can take the similar component, same component, that is k component in one equation and the j component in another equation. That is Q into what is the j component? The j component is here only one component, that is Q into Vx z dot, which is equal to my double dot, and Q into what is the k component? Ez plus Ez minus Vx y dot, which is equal to m into z double. dot is equal to Q into B x z dot by M. Q B z by M. And here z dot is, this implies z dot is equal to, z double dot is equal to Q into Ez by M minus Q into Bx by M into 5. Let QB by M, which is equal to omega, which is known as the cyclotron frequency. Cyclotron frequency, and you have the equation P is equal to, from that you will get P is equal to QBR. So we can write for R, that is V equal to R omega equation, we can write V equal to R omega. So R is equal to V by omega. So with the MV which is equal to cube into B into V by omega, then V and V will get cancelled. So you will get omega is equal to QB by A. This is the cyclotron frequency. This is from the cyclotron formula. You will get the cyclotron frequency. So let QB by M is equal to omega, which is the cyclotron frequency. Then that you can substitute in both this equation. Here you have one equation 1 and you have another equation. This is 2. So you can substitute the value in the equation. That means first y double dot which is equal to QB by M, which is omega z dot, and the z double dot which is equal to, you can write Q into B by B here. So QB by M into E by B will be there. So you can write omega into E by B minus QB by M is there, or then omega into Y dot. So you have two equations here. One is Y double dot and one is the Z double dot. These are the acceleration here. So this is a second order differential equation, and the solution for this equation, that may be a constant coefficient equation. So the solution is of the form, so you can directly write the solution here, that is y is depending upon time and also z is depending upon time. So the equation is y is equal to some c1 cos omega t plus c2 sin omega t plus e by b into t plus some c3. Here also c2 cos omega t minus c1 sin omega t plus c4. These are the two solutions which you may be obtaining from this second order differential equation. So these are the two solutions for the equation which represent a cyclotron motion. So when the particle is at rest, that is when t equal to 0, the velocity as well as the position when it is in the origin, that is the position is 0, and also the velocity is 0 when it is at the origin. So from these two conditions you can calculate the C1 and C2 etc. So after all, after finding the C1, C2, the constants, you will get y equal to E by omega b into omega t minus sin omega t, and z is equal to E by omega b into 1 minus cos omega. These are the two solutions after finding the constants C1, C2, C3 and 64. You will get the formula for yt is equal to e by omega b, omega t minus sin omega t, and zt is equal to e by omega b into 1 minus cos omega t. We can give another condition that r is equal to the radius of this motion, the cycloid motion. R is equal to e by omega b, which r is equal to e by omega b. Then the equation will reduce to yt is equal to r into omega t minus sin omega t. Then zt is equal to r into 1 minus cos omega t. Then you can rearrange the equation taking this r omega r in this side, and then you will get yt minus r omega t equal to minus sin omega t, and zt minus r, which is equal to minus, sorry, this one both are minus cos omega t minus r here r into minus r sin omega t, so here minus r cos omega t minus r sin omega t and minus r cos omega t. So squaring and adding these two equations, so what we will get yt minus r omega t whole square plus zt minus r the whole square, which will be equal to this is r square. So here you can see that this is a formula for a circle with the center at 0, r omega t and r moving in the y direction. So the y direction you have the velocity component here. So this is the equation of a circle having center at r omega t, 0, r omega t and r moving in the y direction. So this motion represents a cycloid motion. We are taking some two substitutions. We are analyzing the cycloid motion quantitatively. So you will get the equation of motion as a circle which is varying with time. That is r omega t is there, which is varying with time. So the velocity is representing that as time passes the position will change. It is moving in the y direction, and this is moving in the y direction with a constant speed. The v is equal to, what is v? V is equal to r omega. Is equal to r omega. So what is r? R is equal to e by v into omega. So which is equal to, so v is equal to e by v. So the velocity is a constant, the overall motion is in the y direction. So the particle is the overall motion when it at a particular time when it is at the origin, then if we measure it will be at another position in the y axis or in the y direction. So the overall motion is in the y direction. So this motion is perpendicular to both the electric field and the magnetic field. The electric field is in the z direction and magnetic field in the x direction. So the overall motion is perpendicular to both the electric and magnetic field. And this motion is, we analyzed the motion quantitatively, and we will obtain the value for velocity, radius, etc. using the analysis here. So we can give certain equations and we measure or we analyze the cycloid motion quantitatively here. And the curve generated in this way, that is the curve generated in this way, it is the trajectory is in this way. This is in the y direction, and this is the z direction, which is ez here, and this is the x direction. Here we have v. So the overall motion is in the y direction. So this curve, this particular trajectory is known as the cycloid motion, or the motion in this particular trajectory is known as the cycloid motion. So that's all about. Thank you.